Hello everyone. Today we are going to solve the active HackTheBox machine. So first we will start with the Nmap scan, and IP address will be so we have found the port 88 Kerberos, and I think I can just do this. And port 389 LDAP and 445 is SMB server message block, which is used for file sharing. So at this stage we can look into that kind of ports further. So grab OP and only digit and slash open and map and code for parse field and paste. Okay, and then go ports, so we can find the ports variable with comma separated list, and then we can use nmap default script version detection and using the port variable and nmap scan again too. So if you navigate this, you can also find the 88 Microsoft Windows and LDAP Microsoft Windows Active Directory LDAP, and 445 is SMB. So we understand that it is Windows environment. So before so at this stage we can find the port 445 SMB port is open. So we have to check what the server simply allows us to see without giving it a valid username or password. So this is called anonymous or null session enumeration. Let's jump into the terminal and see what doors are left unlocked. So we can use an smbmap. We can find that replication is read only, so by default smbmap attempts a null session or login with no credentials. So since we have read-only access to this, we can use like smbclient and with anonymously smbclient we can replication share, which we has read-only access, and we can navigate this easily at this stage. So as you navigate through the policies folders, you are specifically hunting for XML files like groups.xml. When you find one, you have two choices for how to handle it. So more command or groups command. So what we need to do is local change directory and cd police. So ls cd policies. We're going to retrieve all files from the policies. Recurse on from the all and get all. it's interesting that prompt is off, but gives me prompt. So mask. So we can check at this stage. cd so user folder, nothing, machine. There looks to be preferences. Before doing this, I want to retrieve the XML file from this folder, so I'm going to use the bind home kali root and type name I think sorry, it is not Caliban, this folder. So I can find groups.xml file, so we can cat this, then we can find cpassword. So we have found the cpassword, which looks very interesting. So this is Eureka moment in an Active Directory penetration test. But before we crack it, we need to understand the why behind this vulnerability, why does this string even exist, and why is it so famously broken. So back in the day, Windows administrators needed a way to manage local administrator passwords across hundreds of computers. Microsoft introduced a feature called Group Policy Preferences, or GPP. It allowed admins to deploy local user accounts, map network drives, or schedule tasks directly through group policy. To keep things secure, Microsoft encrypted these passwords using AES-256 encryption. If you look at the XML file, the encrypted password is stored in the cpassword attribute. AES-256 is military-grade encryption, so that could be safe. However, they hard-coded the decryption key into the Windows operating system and then accidentally published that exact 32-byte AES key publicly on their MSDN documentation website in 2012. Because the key is public, anyone can reverse the encryption. Let's jump into the terminal and decrypt this. So in the Kali Linux, we can use gpp-decrypt to crack the password. The first will be we need to clone the gpp-decrypt, and we can use this, and then can check the find command. No, maybe we can use this, and python 3 and gpp-decrypt python 3. So we need to check the group's XML file. I think it was this one. Python 3 decrypt. Forgot the argument. So the moment you hit enter, gpp-decrypt takes the base 64 encoded string, run it through the AES 256 decryption algorithm using the public Microsoft key and spits out the plain text GPP still standing strong to K18. So just like that, we have transformed anonymous unauthenticated read access into a concrete set of credentials. We have now have the username and the plain text. So this is a massive turning point in any penetration test. Getting your first set of credentials changes your entire authorization context. Think of it like walking around a corporate building. So in phase 2, we were an anonymous guest. We could only see the lobby and the public directories. Now we just found an employee badge. So we can swipe this badge on every door in the building to see what new areas unlock. Our methodology dictates that the very first thing we do with the new credential is run our enumeration steps all over again. So let's see what this SVC TGS badge gets us. So smbmap IP address was domain should be active HTB and user oh 445 is not open, but it should be. We can check. So we can find that users also have read-only access. So if we go to the SMB client, user share with the active ATB, password should be gpp thing. So ls, so we can also grab like cbsvc, cb desktop. So we can get the user flag there. So after that, so we want to be domain admin at this stage. To get there, we are going to execute one of the most famous and devastating Active Directory attacks, Kerberos-sting. In Active Directory, services like web servers, SQL databases, or file shares need a way to authenticate. To do this, they are linked to a specific user account using a service principal name or SPN. Here is the fatal law. Active Directory is designed to be helpful. By default, any authenticated user in the domain can ask the domain controller for a Kerberos ticket, specifically a ticket granting service ticket, to interact with any service that has an SPN. When the domain controller hands you that TGS ticket, A portion of it is encrypted using the NTLM password hash of the service account running it. So if a lazy administrator decided to run an SQL service with a high privileged domain admin account, we can simply ask the domain controller for a ticket to that service. So the DC hands us the ticket and we take it offline to our HackTheBox to crack the password. That is Kerberoasting in a nutshell. So let's pull out our Unpacked toolset and make this happen. For Active Directory exploitation on Linux, Unpacked is king. It's a collection of Python classes that allow us to interact directly with Windows network protocols. We are going to use a script called getUser_spnpy Python file. So exit this. And this is our authorization process. And so this DC/IP flag is absolutely critical. Kerberos is highly dependent on time synchronization and DNS. If you provide a host name, the script might fail to resolve it and crash. By explicitly pointing DC/IP directly to the domain controller's IP address, we bypass DNS entirely and force the Kerberos traffic straight to the source. So to actually pull the encrypted tickets, we can also ask request flag at the very end. So the request flag tells the script to take that extra step. It identifies the vulnerable accounts and then fires off the TGS REQ ticket granting service request to the domain controller. Once you hit enter, so we can start the password like with KRB5 and something like this. So this is raw encrypted Kerberos ticket, and the $23 $sign specifically denotes that it is encrypted using RC4 HMAC, which is relatively weak and highly crackable. So your job now is to carefully copy the entire string, starting exactly from the $sign in KRB5TGS all the way down to the very end of the hash block, and paste it into a blank text file on your Kali machine. So we can just make file. So after making this hash.txt file, we can maybe check this and hashcat to define like so 13100 should be can be used at this stage. So hashcat and then hash.txt. I think I forgot, and specifying our directory, but I think it should be there is no, because decrypt this again. So ticket master distribute the password. So we can use the SMB client map again, but this time we can use the administrator, and then password should be so this should be administrator, so we can use this. So we can navigate to admin, which has ticket master. I'd like to navigate to this at this stage and see the users, then we can check administrator and see the desktop, so we can get the root shell. So I hope this video should be helpful, and see you next time.